So, a very good morning to everyone, my dearest friends, my future of the country, the future IAS officers, the future IPS officers, the future couples of IAS officers. Welcome back to AKS IAS Academy. So, today we are going to talk a very new thing, a very new important topic with a fresh day, fresh start. That is about 100 most important topic in UPSC. Now we have already did few topics. Yes or no? Yes or no? Yes. We have done few topics. So this is your basically second module where I will try to explain you about the most important topic that may appear, not will appear. I cannot guarantee that. If I guarantee that, I would have been selling one question for 10 lakh rupees by now. So I cannot guarantee that. So basically, I can assure you that they may be asked. You can visit our website www.AKS Academy, okay, and inquire about further details about our contribution to this whole idea of UPSC. Clear? So let's start today's class. Now, we will see three topics today. One is about quantum computing. The second one is about India's conducted first of its kind leader-based offshore wind profile. And the third one, we will talk about regenerative braking system. These are the three topics that we will look today to understand what UPSC can ask from different point of view. So should we start? What do you say? Chiranjeevi? Oh, Arya 2? Oh, Indra 2? Oh, Bahubali? Let's start. So, quantum supremacy and quantum computing are in the news. It happened yesterday. So I couldn't do yesterday. So I'm doing it today, right? Quantum supremacy and quantum computing on the notes. Now, what is this quantum? Quantum, subatomic particles, protons, electrons, neutrons. There is a subatomic particle also, quarks, right? So, anyways, anything that you try to do with these things, right, where you try to use subatomic particle for providing messages, for basically using for your computer and all that, we call that as quantum. Now, this quantum supremacy is used in the context of quantum computers. Today, when you observe a computer that you're looking at right now, or the mobile that you're using right now, use bits to transfer signal. Whenever I say dhira, dhira, so that get transferred as 10, 10, 11, 1100. I don't know about it. I'm not a computer inside this, but they get transferred like this in a normal condition. Whereas quantum computing, for an example, if a normal computer does this at, let's see, 10 bits per second, I'm just giving an example, it's way too higher. Quantum computing will do this at 1000 bits per second because they use subatomic particles. Let's not go into that detail to confuse more to yourself. Just understand that they are very, very fast. They are very, very fast. Okay. And a researchers recently in Google have found out that quantum computers completed a task in 3 minutes, which would require a classical machine for 1000 years. Now you might be understanding, sir, what is this kind of task? Let's see. Tomorrow, I want to find out the monsoon predictive model for India. It will involve putting geographical data, it will involve putting physiological data, this data, satellite, images, ocean, wind, heat, thermal, humidity, and everything. Your normal computer will blast. Whereas quantum computer can do that. That's what you mean by doing it at a faster pace. Okay. So that's why it is in the news. Under quantum computing, it uses a principle of quantum theory, which basically explain the nature, my nature. I am smart, I am beautiful, I am wearing pink shirt. Pink shirt is also Telangana's famous party symbol. So this is my nature. Same way, there are some subatomic particle and atoms. They behave differently when you observe, and when you don't observe, they behave differently. How do? We don't know about it. For an example, an electron when observed behaves like waves. When electron not being observed behaves like a particle. Got the idea? So these quantum theory are used in computer. Together we call it quantum computers. Okay, quantum computers. In that quantum computers, I repeat, quantum computers use the behavior of atomic and subatomic particle when observed for transferring signals. So in that, there is one concept called quantum superposition. What do you mean by quantum superposition? The beauty of this subatomic particle is that they are present in the system in multiple state. When you don't observe them, they behave something else. When you do observe them, they behave something else. For an example, let's see, we have a friend Akash. Akash, when he's alone, will do like this, gir, 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 he'll do like this. When someone is observing, if there is a girl nearby, Akash will do like this. That is why, because there is someone observation. Same way, right, that when we observe, right, and measured, we try to superimpose this, their energy and their material state, and try to make use of it. That is what we mean by quantum superposition, because they observe in different places. The next term associated with quantum computing is quantum entanglement. Quantum entanglement. Now, when you look at quantum entanglement, you need to understand that what you mean by that is that you cannot observe particle independently. You have to observe this particle in comparison to some things, because that's how you can do it. You cannot observe husband singly. You have to observe husband with wife only to understand. Okay, so when you cannot do that, that each particle cannot be described independent of the state of the others. This particle has to be described with the state of this. That is what you mean by quantum entanglement. Even if they are separated by a large difference, we have to make sure that they are basically derived from each other. What are the uses we are using in computing? Just now I told you: satellite data, weather forecasting, supercomputers, missile, nuclear. This requires millions of data. Quantum communication, yes. Today you use optical fiber. Let's say if it's transferring 10 bits. Tomorrow if you use quantum communication, it will transfer 1 lakh bits. You know what do you mean by 1 lakh bits? It will be the fastest computer ever done. Okay. So that's why you need to understand that quantum computing, communication have their own usage. Okay. Are we clear about it? Are we clear about it? Very good. Quantum meteorology, I already told you. Observe the earth, it's deep. It requires so much of data. So that's why I use it. But please understand, quantum computing is a basic science. Physics, basic science. Chemistry, basic science. Biology, basic science. Biotechnology, applied science. Engineering, applied science. So just in its stages of building. For an example, laser was invented by Einstein in 1916, but to make the actual use of laser, it took us 44 years. Today that you're seeing your broadband TVs, it was in news 16 years back, 16 to 20 years back in India. I'm talking only about India. In world, it started way 30, 40 years back. To come to your level of internet, it took 2019. So that's why it will take a lot of time before these things become an actual reality. Are we clear? Please ask me any doubt if you have, even if you don't have. Now, India conducted first of its LIDAR based offshore wind profile at Gulf of Khambat in Gujarat. Gulf of Khambat and Gulf of Mannar, you should open up your geography book. You should open up your geography book and then go into the detail. Where are they present? How is their structure? Which state? How and everything. Okay. There are the two places in India, one in Gujarat and the other one in Kanyakumari, where there is a potential, wind energy available. Okay. So that's why we did this research. We have been doing it, but this is the first time we use LIDAR. LIDAR stands for light detection range and ranging. Basically, it's an equipment that measures the wind speed. Hawaii, that measures the wind speed and direction at heights by using laser lights, okay, by using laser beams, and they track the motion of the particles, and we'll tell you about it. Why offshore? Easily, economically, renewable resource of energy, wind energy, and on the sea would make a lot of difference, although it would damage the marine ecosystem. Okay, so tomorrow please locate this on map. Gulf of Khambat and Gulf of Mannar. Please locate them. I'm repeating, please locate them on the map. Their structure, their position, and why only these two places. Why only these two places are, although India has such a big coastline, why only these two places? There is a, there is a, what you call potential for wind energy. Please try to find out. I will be very happy about it. The third and the last topic of the day, which is regenerative braking system. You know what is your braking system? You use car, you use bike. So this is your car disc. You apply brake. There are two things that will hold this disc. Okay. And basically the car will stop. Whereas in a regenerative braking system, whenever the vehicle slows down, you are going fast, but now you are completely slowed down. Now you are moving fast because kinetic energy, the energy possessed by the body because of this motion, K, right? K is equal to half mv square. Remember, half mv square. So what they do is that whenever the vehicle slows down, it will convert the kinetic energy, because there is a change in velocity, to it will change its uses velocity to convert it into kinetic energy. And then this kinetic energy can be converted into different forms and stored. For an example, you use your car, you put up this motors here. Whenever car slows down, goes up, there is a change, rate of change of velocity, right? There is an acceleration, there are changes. You save that energy, use some instrument to transfer that into battery, and use this battery either to run your car or to run your laptop or to run your house, whatever it is. What is the difference? Difference is nothing. When you apply the braking system, because of the friction, the car or the bike stops. This is normal one. Friction, heat, energy is lost. Here, the same thing, instead of friction, I am trying to convert that energy into useful energy, that is kinetic energy, and then converting into normal energy. Because please remember, Einstein told, energy can neither be created, cannot be destroyed. It can be only transferred from one form to another form. So they might give you a prelims question tomorrow. Which of the following principle regenerative braking system works? Straight away answer, it is nothing but your law of conservation of energy. Okay, law of conservation of energy, law of conservation of energy. So this is for today. 3 topics, 6 topics have been done. Important topics for your this year prelims. Please go through them. Definitely it will be helpful. Goodbye. Take care. Bye bye.